A what? You won't need it today. It doesn't matter. The quiz I told you on Friday would not be on a Chromebook. It's on paper. So there's no Chromebook needed for class today. All right, folks, could you please take out your pencil, your calculator, and the lab number 1 worksheet. Pencil, calculator, and the lab number 1 worksheet, please. I am moving your quiz on algebraic manipulation to tomorrow. I'm trying to keep your class in sync with the others, and one of my other classes is really not ready for that quiz today. So I've decided to push it back for everybody to tomorrow. So that gives you an extra day to get that homework done if you did not. That was on Friday. To get that homework done for tomorrow. I'll check it in class tomorrow. Study. Tomorrow's quiz is not on a Chromebook. You have to show me how to manipulate 3 equations on paper tomorrow. All right. Your assignment tonight is therefore to finish that homework if you didn't. Get it done for tomorrow, which was in your packet. Study for that quiz. And then I'm going to ask you to finish 2 questions on this lab for homework for tomorrow. So I'd like to do this first. Let's go through the other questions on this lab. Don't jump ahead. You have never done a physics lab, so you have no idea what we expect you to show in order to get full credit for the questions, okay? Your job will be to answer questions 6 and 7 on this lab for homework for tomorrow, and I will collect this at the start of class, okay? Then once we finish this, we'll go back and look at those 2 questions that we did not finish on page 13 in your packet. All right, so let's get started with this lab. Any questions on that assignment? Should be pretty straightforward. You're going to answer those questions in complete sentences. Okay. So let me shift over to that lab. And let's get going. We're going to do this together. You've got your calculators, so that way you can do the calculations with me. Number 1 tells you that the accepted values for the length and width of this piece of paper are 11 inches and 8.5 inches, respectively. I want you to use the factor label method, which is what we learned how to do in class last week, to convert those values from inches to centimeters. I'm going to do it with you, and I'm giving you the conversion right here. Okay, so let's start with our length conversion. First of all, which of these values is the length? Is it 11 inches or 8.5 inches? 11 inches. So we're going to take that given value, 11 inches, and put it over 1. We always start by taking our given value and we put it over the number 1, or we write it as a fraction. Now you have to multiply by a fraction, which will show those units canceling, giving us centimeters. So where does inches have to go in that fraction? Top or bottom? Bottom. Now here is the conversion factor. So that means I'm going to put 1 inch in the denominator and the equivalent conversion factor, 2.54 centimeters, in the numerator. So now I can see the inches canceling. Remember, you've not done a physics lab before. I expect you to show this work. Basically, you are just copying what I have on the screen onto your paper, and then you'll get 100. Let's now go ahead, multiply that out on your calculator. Please make sure your calculator is not in the scientific mode for this lab, okay? Get it out of the scientific mode. There is nothing here that requires scientific mode. Multiply it out, and what does your calculator tell you? Vincent, you got it? Good. Now, that is not our final answer. We do have to pay attention to significant figures. The way we do this is we look at our starting measurement to determine the significant figures. How many significant figures does 11 inches have? So what am I going to round the answer to? 2 sig figs. So the answer is 28. And the units on that? Centimeters. Box it in. That is your length. Now you're going to do the same thing for the width. What is the given measurement for the width? 8.5 inches. So we're going to take 8.5 inches, put it over 1. We are going to multiply by that same conversion factor so the inches cancel. So it would be 2.54 centimeters over 1 inch. Now we can see those inches canceling. We're going to multiply that out on the calculator, and we're going to take the calculator answer and round it to the appropriate number of significant digits. How many significant digits do we need on this answer? Also 2. So what is the final answer to this? Miriam, you have it? Excellent. 22 centimeters. We're going to box it in. We make sure we have units after every numerical value that's there, and we are good. Any questions on number 1? That's a review of factor label method. Let's then go on to question 2. Number 2 says that we're going to use those accepted values for the length and width in centimeters. So it's telling you what your givens are. We want to calculate the perimeter of this piece of paper. And this answer will be our accepted value for the perimeter of the paper. So we're going to use our guess method to solve this. So remember, in the guess method, we start by listing our givens, which are the length and the width in centimeters. Now, where am I going to get the length and the width in centimeters? Answers to number 1. What was the answer to number 1 for the length? 28. What? 28 what? cm. And what was the answer for the width? 22 cm. All right, now we have to identify the unknown letter for perimeter. You want to take a guess what letter we use for perimeter? Capital P. This is not on your reference table, capital P. Now let's review how you calculate the perimeter of this piece of paper. What shape is it? It's a rectangle. How do you find the perimeter of anything? No, you do not times anything. What do you do to find the perimeter? You add up all the sides, which means the perimeter would be the length plus the length plus the width plus the width. That would be our equation. P equals L plus W plus W. Next step is to substitute in those given measurements and their units. 28 cm plus 28 cm plus 22 cm plus 22 cm. Now you're going to go to the calculator, add up those numbers. And what does your calculator give you? It gives you 100. Now, we can start with the 100. What units is this going to be in? The units are what? Centimeters. Okay, we are not done. We got to think about an answer with proper significant digits. Remember that the rule for addition is we count the number of decimal places to the right of each measurement. How many decimal places do I have to the right of each of these measurements? None. I don't have any here either. But right now, this is only precise to the hundredths place. These measurements are precise to what decimal place position? What do you call that decimal place position? The ones, which means this answer needs to also be precise to that ones place. How do I make that 0 in the ones place count, therefore, as a significant figure? Add a point at the end of it. And now that 0 is a significant figure because of the Pacific rule. That is the final answer. Without that decimal point, it would be marked wrong. Questions? Yeah. Okay, because all of our measurements are precise to the ones place. That means we need our ones place digit to also count as a significant figure. Without that, we use the Atlantic rule and we would count this way. The only digit that would count is the one in the hundreds place. To get the ones place digit to count, because it's a zero, you got to put a point. If it were not a zero, it wouldn't matter. Okay, let's go to number 3. Same thing. I want you to use the accepted values for the length and width in centimeters to now calculate the area of this sheet of paper. So again, use your guess method. The given value for the length is what measurement? 28 cm. What is the given accepted value for the width? 22 cm. Make sure you have a cm after everything. We are very particular about that in this course. The unknown letter, what do you think we use for area? Capital A. That's right. A lowercase a means something else in physics. So if you put a lowercase a, I would have to take off of that. It stands for something called acceleration, which is not anywhere related to an area. All right. Think about the shape of this piece of paper. How would you find the area of this piece of paper, Chaudhry? Give me an equation to write. Okay, the equation doesn't have any numbers in it. There you go. Area, A, equals L times W. We show it with all of the variables. That's the equation. Now it's already solved for A, so we can go to our substitution with the units. So A is 28 cm times 22 cm. So let's go to your calculator and get a calculator answer. And what does the calculator tell you? 616, right? Okay. That has too many significant figures. Remember, the rule for multiplication is you count the number of significant figures in each measurement. 28 has how many significant digits? 22 has 2. So how many do I need in my answer? Okay, that means we're going to round to the second digit in our value, which happens to be in the tens place. So the answer would either be 610 or 620. Which one's the right answer? What is it, Haley? 620 is correct. And what units are we going to put on that? Centimeters squared is correct. Any questions on 2 and 3? Okay, you are going to do the same thing in 4 and 5 right now. But the givens are the averages that your group calculated in table 1 and table 2. Okay, so when I do it, I'm not going to have the same numbers as you. I will show you how to set it up, but I'm not going to get the same answers that you and your group members will. So I'll give you, let's go ahead, just set it up again. Using your guess method, you're going to get the average of the measured value for the length, which is at the end of your first table. You're going to put that as your given value. Whatever your group got, that was what my numbers came out to be. And then you're going to do the same thing, get your average from your width table. So look back at your width table, get the average number that your group came up with, take that and put that here. 1.56 cm. Now the unknown in number 4 again is we want to come up with our perimeter. That is capital P. The equation that you're going to write is the same equation you had in number 2. Then you're going to do your substitution with the units. You're using your numbers, not mine. My measurements came from a lab that was done a couple of years ago. And then you're going to go to your calculator and get an answer with the proper precision. You shouldn't get that. You're going to get whatever your group's numbers give you. I'm just showing you how to set it up. I'm modeling for you what you would do if those were your numbers, but they're not. So you got to put your numbers in there, get your answer. Remember, the rule for addition is we count digits to the right of the decimal point. Each of your measurements for your averages have 2. So you have to round to the second place to the right of the decimal point, which is in the hundredths place. So your answer should go to the hundredths place. Number 5, you're going to do the same thing, but you're not going to find the perimeter. What are you going to find? The area, using those same givens that you had in number 4. You're going to use the same equation you had in number 3. You're going to plug these measurements in with their units attached to them. And then you're going to solve it. And here again, remember, you have to pay attention to the number of significant figures on your answer, not the precision. How many sig figs are our answers for the area going to have? 4. So you're going to round your answer to 4 significant figures. And box it in. Okay. Let me give you a minute for you to check your answers to 4 and 5 with the people you collected the data from in this lab. Check your answers to 4 and 5 with the people in your group, because you should have the same answers as the people in your group. Because I know we checked our averages last week when we were collecting the data. So this is just checking your answers to 4 and 5 to make sure you agree on what those final answers are.
Yeah.
Yeah, don't watch. All right. We're non-internet connected. All right. Let's just talk about what these answers are. In number 2, we are telling you that this answer is your accepted value for the perimeter. So let's just make a note here. This is the accepted perimeter. Number 3. This answer in number 3, we are told, is going to be the accepted value for the area. So this is the accepted area. In other words, when we did our calculations, this is what we expect to get if we did everything perfect. When you do a lab, is everything going to work out perfect? Never. Never. If it does, everybody's going to go, what the heck did they do? They fudged everything they did. And we don't fudge data in labs. We expect things not to be perfect. All right, let's go to numbers 4 and 5. What are these answers? Number 4, this answer, we are told, is our experimental value for the perimeter. Or we could say this is, we didn't measure it, but it is our measured or experimental perimeter. And number 5, we are told, is our experimental value for the area. So let me just go over what 6 and 7 are asking you about. And you're going to answer these 2 questions for homework. If you neglect to do these, you will lose 2 points on the lab because you do not get time at the start of class tomorrow to answer them when I collect it. When I'm collecting it, it should be done. Okay? So if you just forget to do it, you're just going to lose 2 points out of 10 on the lab. You're down to an 80% as your possible highest grade you could earn. And if everything else was done exactly as I showed you to do it. In number 6, I am asking you, which experimental value, here are the 2 experimental values, is the more accurate answer? Which one's more accurate? And then notice it asks you to explain. Explain means, how do you know it's more accurate? That's what I want to know. Which of these 2 values that we calculated is a more accurate answer? And how do you know? That's what I want to know. So a correct answer would take the form in a complete sentence. I'm going to review what a complete sentence is because I know we're so used to texting and abbreviating things. We never abbreviate on a lab. You write everything out. We're never going to put BTW or an LOL on your page. If you do that, you have a 0 out of 10. Okay, this is not a place where we write like that in a professional way. So we would say something like, my experimental blank is more accurate because, and you're going to fill in after that. You know what I mean? That's how you're going to, that's the form of your answer. And we end it with a period, so it's a sentence. Number 7 is asking you, which of these answers in 4 or 5, which of these in 4 or 5 is a more precise answer? And again, explain. So you would say something like, my experimental blank is more precise because, and then fill in the blanks. Make sense? So if you don't remember what accuracy or what precision is, that's where you're going to go back to your homework that we've done on accuracy and precision. You're going to go back to your class notes on accuracy and precision and review what those are. Any questions on this? You're going to answer those 2 questions for homework tonight. Please put this away, and let's now go to your packet. And in your packet, I would like you to turn to page 13. Let's turn to page 13 in your packet. You will also need now your reference table because we have to look up physics equations to finish this problem-solving business that we were looking at the other day. Okay. So if I remember correctly, we were on problem 4. At least that's what I have written down. And we were trying to figure out what the area of a circle with a radius of 2.0 meters is. And we listed our given value, but we didn't get to the unknown variable yet. If you recall, which section of the reference table is this problem going to come from? The geometry section. That's right. So could we all please turn to page 5? in your reference table, and let's look at these geometry equations. The unknown variable letter has to work with the area of a circle. So when we look at the right-hand column, what letter do we use for area? Capital A. So that's what we're going to list as our unknown letter, capital A. All right, the next thing we do is we look for our equation. So when we look at page 5, we're going to narrow down these equations to the shape of the figure in the question, which is a circle. So which equation are we going to use? Haley? That's correct. So let's write that as our equation. A equals pi r squared. Now, do I have to do any algebraic manipulation on that equation? Absolutely not. It's already solved for A. So we can go directly to our substitution of the measurement. A is pi times the 2.0 meters squared. Now, every calculator that you're using in this class, because it's scientific or graphing, has a pi key on it. Do you know where the pi key is? That's what you're going to use. We're never going to use 3.14. That's a truncated value. So we don't want to use that. We want to use our pi key. So go ahead and plug that into your calculator and let's get an answer. I gotta figure out where the heck is the pi key on my graphing calculator. Where's the pi key on your graphing calculator? Second caret? Yes, thank you. I'm used to using a scientific one, not the graphing, but my scientific one is being borrowed by my daughter today, so I'm out of luck with that. All right, how many significant figures is our answer going to need? 2.0 has how many significant digits? 2. Pi is an exact value out. It goes on forever, so we don't count that. We just look at the measurement that has 2 sig figs. So you want to round your answer to 2 sig figs. What's the answer going to be? Nikolai, can you tell me? 13 meters squared. All right, last step in the guess method is to do the dimensional analysis, which is the check. We want to check that meters squared matches the answer, the units in our substitution. So we always rewrite our equation first. Rewrite the equation. Now, what units did we get for the area? Meter squared. These are not supposed to be hard questions. You get meter squared. Does pi have a unit? No, it's a ratio of sides. So pi, we ignore it. It's not part of the units. This is just about units, so we ignore it. What are the units for r? Look back at your givens. What's the unit for r? Meters. But you gotta square it. Does the left side equal the right side? Check. Done. It really is supposed to be, in some cases, that easy. Okay. Let's go on to the last physics question, number 5. We have no. You guys were reading this, if I remember right, on Friday as we were going around the room. Who wants to start us off? I don't remember where we left off Friday. Read the question to the class. Elisa, can you start us off? Very good. Okay, so Maxwell, remember we start by circling things that were being given in the problem. Can you tell me the first measurement I should circle in this question? So what measurement do we have for that? What measurement? I need a numerical value with a unit attached to it. Okay, so 60 kg. We're going to circle that. Khalees, can you tell me the other measurement that I'm being given in this question? 5.0 m/s. Jackson, can you tell me what word I should underline that I am looking for? Momentum. Okay. So now we're going to take these things that we've circled and underlined and try to translate them into our givens and unknown list. So we're going to start with this 60.kg. Remember that kg is kilograms. Do you remember what kilograms is a unit of? Based on the notes we took the other day, fundamental units, kilograms a fundamental unit in physics. Shelley, do you remember what kilograms is a measurement of? Can anybody help her? Blake, do you remember? Not weight. It's similar to a weight, but it's not weight. It's a mass. Okay. Before we try to figure out what letter we use to represent mass, we have to figure out which section of the reference table this is going to come from. So if we start on page 4, which is where the equations begin, remember we have electricity. Do you think this question involves anything about electricity? No. Does it involve anything about a wave? No, it didn't say anything a wave. Did it talk about anything modern like Einstein? No. Was it involving any geometric shape? So guess what's left? There's only one section left. That is mechanics on page 6. This is the biggest set of equations we have for the entire course. And this will take us till the end of January. First week of February is when we will finish learning about mechanics. We're going to go here starting next week. Let's look at the right-hand column to figure out what letter we're therefore going to use for mass. You correctly identified that kilograms is a mass measurement. So what letter, according to the list on the right, is mass? Emma? What letter do we use for? Yes, lowercase m. So little m is 60.kg. Now we have to look up this value, which the question tells us is a velocity. Let's look at the right-hand column again to find the letter that we use for velocity. Flavia, can you tell me what letter we use for velocity? That is correct, a lowercase v. So lowercase v is 5.0 m over s. Notice that if you just wrote 5 m over s instead of 5.0, you just changed the significant figures in the question, which would be wrong, right? You're going to end up with a wrong answer because you're getting sloppy and dropping things. You want to make sure you include those point zeros here. I know that's new, but that is something we have to pay attention to in physics. Okay, now we have to look up the unknown variable letter. We said the unknown variable is the word momentum. Haley, if you look at the right-hand column, can you tell me what letter we use for momentum? That is correct. It is a lowercase p, not a capital P. Capital P stands for something else. All right, now we have to locate an equation that we can use that has a little m, a little v, and a little p. Gavin, can you find an equation on the left-hand side that has those letters? That is right. P equals m times v. We ask ourselves, is this question solved for the variable I want? P? It is, so there's no algebraic manipulation to do. We can now do our substitution with units. So little p is 60.kg times 5.0 m over s. We're now going to solve it. And Ryder, what does the calculator give you when you do that? That's right. And that is not going to be our final answer. Let's talk about sig figs. How many significant digits does 60 point have, Janisa? 2. How many, Kira, does 5.0 have? 2. So Miriam, how many sig figs do I need on this answer? 2. All right, if I write it without the decimal point, how many sig figs does it have? 1. That's no good. If I put the decimal point at the end, how many sig figs would it have? 3. Oh, you remember what we have to do when we get into that conundrum where the number we want is between what we can get with and without the decimal? What do? Scientific notation. So go ahead, just put your calculator in the SCI mode and do it again. And what's the calculator going to give you? The units will remain the same, but what does the calculator say it is? 3 times 10 to the 2. Now, right now, that has 1 sig fig. I need it to have 2. So what do I do? Do you remember what we do here, Sydney? Yes, 3.0 times 10 to the 2 kilogram times meter per second. And that's what we're going to box in as our final answer because now that has the 2. This only had 1 or 3, depending on whether we have it or not. Last step, check it. P equals MV. Vincent, what units did we get for P? Correct. What unit did we have for mass here, Ryan? Masses in this problem were measured in what unit? kg. And V, Jacob, is measured in what? What units for V? Okay. Does the left side equal the right side, Alex? We're done. Any questions on page 13? For those of you who are not here on Friday, because you were at the Scholars Breakfast, make sure you go back, watch Friday's video so you can get the other 3 and the notes as well, because that guess method helps you get a 65 on the Regents exam. I want to make sure you can do that. How are we doing with time? We have 5 minutes. I bet you in this 5 minutes of class, you can get questions 6 and 7 on your lab done. Right? You probably can. Go ahead and work on getting those 2 questions done. Questions 6 and 7. I will collect that at the start of class tomorrow. When I come around to check that page 12 in your packet, algebraic manipulation was done for class as well. Okay. Yeah, hold on one second.